In this video, we're going to solve some equations that have radicals in them. So I want to go back to some really simple ideas, but it's in an effort to make some sense out of what we're going to do. When you solve an equation and you have x plus 2 is equal to 7, you look at this and say, I need to get rid of that plus 2, and you use the inverse. The inverse of addition being subtraction, and you subtract 2 from both sides. And that's how you, and I'm using quotes, get rid of things you want to get rid of. If you had 5x is equal to 10, there's multiplication going on here. The inverse of multiplication, is division. So where that's multiplied by 5, I'll divide by 5. So I have x is 2, and so on. Well, we're dealing with square roots. The inverse of a square root is squaring. So I'm going to use squaring. One other thing that I need to caution you about is domain. The square root of x, it has a domain being what you can plug in for x. X must be greater than or equal to 0. In other words, it can't be negative. So kind of keep that in mind. And one other thing to notice, and these are just little facts I'm throwing out, and they'll all kind of come together as we work on these problems. If you have a negative quantity and you square it, it becomes positive. If you have a positive quantity and you square it, it's positive. These were completely different bases, and yet the value over here is the same. So when you square quantities, you make some sign changes possibly. Okay, I've just thrown out some seeds of information, and they won't make a lot of sense until we get into the problems. Let's look at our first equation to solve. I have the square root of x minus 3 is equal to 7. When we're going to solve an equation with a square root in it, the first thing you want to do is isolate the radical. If it's something added to it on the outside or subtracted from it on the outside, you're going to get rid of it. But this radical has already been isolated. Since this is already isolated, what I'm going to do is do the inverse, trying to get x out of the radical. I'm going to square the left side, and square the right side. So I have x minus 3 under the radical, quantity squared, equals 7 quantity squared. So you have to square both sides. Remember, when you square a square root, it pops out. So when you square this square root, it comes out as x minus 3. When you square the right-hand side, you get 49. Now, you just have a plain old linear equation to solve in this problem. Add 3 to both sides, and x is equal to 52. All right? So, the radical needs to be isolated, nothing added or subtracted from it on the outside, nothing times it on the outside. If it is, then go ahead and square both sides and solve what you get. Oh, let me go back to that problem. I forgot something very important. The act of squaring both sides can cause you to think you have the right answer when you might not. You literally have to check these. And I almost didn't. So, question, is the square root of 52 minus 3 equal to 7? And you have to check them in the original form. So 52 minus 3 is 49. And what is the square root of 49? It's 7. And the right-hand side is 7. So this one checks. You have to check it because that process of squaring could cause something to change its sign and appear to be the right answer that won't check in the original. Let's look at another one. I have the square root of 7x is equal to -9. The radical is isolated, so I will virtually copy the problem down, but I need to square both sides. When you square a square root, the radicand pops out, and this time I'm squaring -9. That will give me 81. 5 by 7, 5 by 7. I know it doesn't go in evenly, but that shouldn't bother us. I get 81/7. All right, so we're going to check it. Always going to check it. When you square both sides, you invite an answer that won't check. So the square root of 7 times 81/7 is equal to -9. 7 times 81/7, those little 7's will cancel out. So I have the square root of 81, -9. What's the square root of 81? It's 9. The other side is -9. That's not true. They are not equal. This does not check. And you can see that it's off by a sign. And when you're doing a check and it's off by a sign, it has been caused because we squared. The square root of this quantity can't equal a negative. But when I squared it, I no longer had a negative. So this is not the answer. So in this problem, I will click there is no solution. There's a solution to the equation you get after the squaring, but there's not a solution to the original. All right, the next one, I have the square root of 6x minus 5 minus a 5 is equal to 0. The radical is not isolated yet. So to isolate it, I will add 5 to both sides, and I have the square root of 6x minus 5 is equal to 5. Now I'm going to square both sides, and I'm going to be a little lazy, use a little shortcut. I'm going to do it right here on this side once it's been isolated. You notice I didn't rewrite it. When you square a square root, the radicand comes out. Square 5 for 25. All right, let's keep going. We will add 5 to both sides. I have 6x is equal to 30. Divide by 6. X is 5. But we are curious, or at least I'm curious, will 5 check? Let's see. Remember, check it in the original. Checking 5. Is the square root of 6 times 5 minus 5 minus a 5 out here equal to 0? Under the radical, 6 times 5 is 30. 30 minus 5 is 25. So this is the square root of 25 minus 5 is equal to 0. The square root of 25 is 5. Minus that 5 is equal to 0. And that is true. 5 minus 5 is 0. 0 equals 0. It checks. And I will tell you something that is, it won't be asked in any of your problems, but in our previous example, when we got an answer that didn't check, there's a name for that. It's called an extraneous, solution. Extraneous being the adjective form of the word extra. So it's an extraneous solution. Number 4. I have the square root of 5x is equal to 15. Is the radical isolated? Yes. So I'm going to use my shortcut and go ahead and square the left side and square the right side. We know that when you square a square root, the Radicand pops out, so I get 5x. When you square the rational number 15, you get 225. Divide both sides by 5. X is equal to, I get 45. But I do need to check it. I need to see if I've got an extraneous solution. I have the square root of 5 times 45. Is that equal to 15? Well, 5 times 45 is 225, still under the radical. Is that equal to 15? The square root of 225 is 15, and it is equal to 15. So that checked. If it's going to be an extraneous solution, it will not check, but the problem will be with a sign. All right, we have 2 more to look at. Number 5, I have the square root of x minus 15 is equal to 3. Is the radical isolated? Yes. So, whoops, let's square both sides. When I square a square root, the radicand pops out, so that's x minus 15. Square a 3 for 9. Add 15 to both sides, and I get x is 24. I need to check that, make sure it's not extraneous. I have the square root of 24 minus 15. Is that equal to 3? 24 minus 15 is 9. So is the square root of 9 equal to 3? And the answer is yes. 3 is equal to 3. That checks. We have one more. I have the square root of 7x minus 6 minus 6 is equal to 0. All right, the radical is not isolated yet, so I will add 6 to both sides, and I have the square root of 7x minus 6 is equal to 6. Now it's isolated. I will square that side, and I will square that side. That gives you 7x minus 6, because when you square a square root, the radicand pops out. 6 squared is 36. Add 6 to both sides. I have 7x is equal to 42. Divide by 7. X is equal to 6. This is very similar to a problem I had a few minutes ago, but it seemed like there were 5s in it. When I check it, the square root of 7 times 6 minus 6 minus 6, does it equal 0? Let's go inside the radical. 7 times 6 is 42. 42 minus 6 is 36. It's under the radical. Minus 6 is equal to 0. The square root of 36 is 6. 6 minus 6 is 0, and it's equal to 0, so that checks. We only had one problem in this exercise that had an extraneous solution, and sometimes you can even predict it's going to happen when you isolate the radical and it's equal to a negative. That is a pretty good indicator that the answer you get will not check. Okay, solve your equations in your homework set.